Okay, so let's start out today by thinking through the problem of when firms are going to be willing to invest in workers' skills when those skills are useful in a variety of contexts. In other words, if you imagine that you're a firm that would benefit from having workers who are better at Excel or better at Stata or statistical analysis more broadly, when is it going to be worth it for you to engage in costly training for your workers now in the hopes that they'll become more productive later? And just to simplify this problem and to think through it, let's start out by analyzing a particular version of this. So to start out with, we're going to think about just two periods, right, now and later. And what we're going to assume is you get more productive later with an investment, but it's costly for the firm now. And we're also going to assume, in order to make this a little bit easier to think through, we're going to think about this in the context of a perfectly competitive labor market. Which of course is going to mean that in the long run equilibrium, firms are in zero profit. And means that workers can get whatever wage they're being offered by one firm at a variety of other firms, right? So firms don't face an upward sloping supply of labor, they face a perfectly elastic supply of labor. Okay. So what we want to know, right, is given these assumptions, is it possible for it to be worthwhile for you as a firm to invest in your workers' skills if those skills are going to make your worker productive across the board? Productive with you, but also productive with other firms that could potentially hire them. So to think through this problem, what we need to do is start by thinking about what the firm's objectives are, and then think about what's consistent with those objectives. So as always, right, we're going to assume that the objective of a firm is to maximize their profits, right? The firm wants to make as much money as possible. But because we've got two periods here, we're going to have to be a little bit more careful than that. Because instead of just saying that the firm is going to maximize their profits at some particular moment, we want to say that the firm is going to maximize the value of their profits over both of these periods, right? The value of their profits in period one plus their profits in period two. And as we talked about in last lecture, the way we're going to do that is to assume that firms are going to maximize the present discounted value of their full stream of profits. So firms maximize, which I'll call big pi of H, where H is the amount of human capital they invest in their firm, is going to be pi 1 of H. That is their profits in period 1 plus 1 over 1 plus R times pi 2 of H. Why 1 over 1 plus R? As we talked about last time, right, the value of $1 earned in period 2 is going to be less than the value of $1 earned in period 1, because if I earned, say, let's say I earned $100 in period 1, and I had an interest rate of 10%, if I put that in the bank, or I invested it at that interest rate, I would have $110 in period 2. And likewise, right, if I earn $110 in period 2, that's only worth as much as $100 in period 1, because if I wanted to borrow against those future profits and bring them into period 1, I would only get $100 in period 1 from the $110 I earned in period 2. Okay, so we're going to maximize the present discounted value of our profits in period 1 and period 2, which in turn are going to be our revenues in each period minus our costs in each period. And for simplicity, let's extrapolate away from the problem of how many hours a worker is going to work. So we're going to think about their wages as their annual salary and their marginal revenue product as their annual productivity. So then we'll write pi h is going to be our period 1 profits, which is our marginal revenue product in period 1, minus our costs in period 1, which are going to be the wages we pay our worker, W1, plus the cost of training our worker, H. I'm also going to assume, by the way, for now, that there's a constant cost of each hour of training or each unit of training I give my worker. And I'm going to measure my human capital investment, H, in terms of dollars. So I'll just say, the cost of H units of training is just H. And then plus my profits in period 2 discounted by 1 over 1 plus R. That's going to be 1 over 1 plus R times my marginal revenue product in period 2 minus my wages in period 2. So one thing I want to note here, you'll note that some of these I'm writing as functions of H, some of them I'm not. So I just want to explain why I'm doing that. So my marginal revenue product in period 1, my workers' productivity in period 1 doesn't depend on their human capital investment, right? Because we're going to assume that human capital is only going to be worthwhile to my worker, is only going to increase my workers' productivity in period 2. So I'm going to have marginal revenue product in period 1 is just given by the world. Marginal revenue product in period 2 is going to depend on how much I invest in my workers' skills. On the other hand, both wages, W1 and W2, I'm going to write as functions of human capital because it's possible, and we're going to be exploring this possibility, that the wages I have to pay my worker in period 1 and the wages I have to pay my worker in period 2 might both depend on the amount of human capital that I invested. Okay. So given all of this, we know that there's a cost to investing in my workers' human capital that comes from the fact that I have to pay H in period 1. So what that means is there's two things, one of two things or both of two things must be true in order for it to be profitable for me to do so, right? In other words, in order for it to be worth it for me to invest in human capital. The first possibility is that I'm going to earn more money than I pay my worker in wages in period 1. In other words, my worker is going to be paid less than their marginal product in period 1. And the second possibility is that I can pay my worker less than their marginal revenue product in period 2. You can see one of these two must be true, right? Because these are the only ways that I could get a return on my human capital investment. So let's think a little bit about which of these is likely to be true. And I want to start, I'll give you a moment to think. And then I want to start by thinking about this second possibility, because this is really the more natural possibility, right? We know that we're increasing our workers' output in period 2. We're making our worker more productive in period 2. So the natural thing to think would be that the reason it's worth it for me to invest in their skills in period 1 is because I benefit in period 2 from their increased productivity. But let's remember that we're in a competitive labor market, a perfectly competitive labor market, and that the skills that I've invested in are things like Stata or Excel or project management or things that are valuable to a lot of other firms. And so as a result of that, my workers' marginal revenue product doesn't just go up for me when I invest in their skills, it also goes up for everyone else. And so if we think about the minimum wage I'd have to pay my worker to keep them working for me, it would be whatever wage they could get at some other company. So because other companies should be willing to pay a wage in period 2 equal to my worker's marginal revenue product, right? Because of the fact that my worker's more productive for them as well, I would also have to pay W2 of H equal to marginal revenue product. Right? other words, this possibility is not real. The reason that I'm not going to be able to earn a profit from investing in my workers' skills by recouping that investment in the later period is because all I've done is made my worker more expensive to the exact same degree as I've made my worker more productive. So I can't benefit in period 2 from training my worker. So what that leaves is this, right? It must be the case that in order for it to be profitable for me to invest in my workers' skills, it must mean, investing in my workers' skills must mean that I can pay them less than their marginal revenue product in period 1. And because of the fact that the marginal revenue product in period 1 doesn't change when I invest in human capital, this must mean that I can pay my worker less because of the fact that I'm investing in their skills. And in fact, because of the zero profit condition, and because of the fact that we know that our profits in period 2 are equal to 0, it must be the case that our profits in period 1 equal 0. So we must have that our marginal revenue product in period 1 equals our wages plus our human capital investment, right? In other words, our wages in period 1 are going to be our output as a worker in period 1 minus the investment that our boss is making us. And this absolutely must be the case if it's going to be the case that it's worth it for firms to invest in their workers. So that leads us to a question. Why would it be, as a worker, that it's worth it for me to accept a wage that's below what I'm producing? And remember, this is a perfectly competitive marketplace, right? There's plenty of employers to choose from. So I should be able to find an employer that's willing to pay me my marginal revenue product. So why would I take this wage hit? Well, the answer for this comes from what we just did, right? The reason I'm willing to accept this lower wage as an employee in period 1 is because of the fact that in period 2, that increased productivity is going to result in greater skills for me. In other words, because I get the benefit of that increased human capital, I'm also going to be willing to pay the costs. Another way to think about this is that fundamentally, general human capital is just a non-wage amenity. In other words, it's something that employers are willing to provide to employees because even though it's costly to employers, it's valuable to the employees. And when we think about how much of this general human capital firms are going to provide, we can think about it in exactly the same way as any other non-wage amenity investment, right? We can say firms and workers are going to agree on a combination of compensation that's Pareto optimal, right? Where there's no way for the firm to make their employee as well off without raising the firm's costs. There's no way for the employee to give the firm better profits without lowering the employee's well-being. Okay, so this leads us to the question of how much general human capital investment firms should provide to their workers. And we can analyze this question in exactly the same way that we would analyze any question around non-wage amenities. So we would have to say, what are the workers' preferences? What are the firm's profits, which is going to be equivalent to what are the firm's costs? And then where can we find a Pareto optimal combination? So let's start by thinking about what the workers' preferences are going to be. And let's imagine, like we did in last lecture, that we have a worker who's not credit constrained, right, who can freely borrow and save money. So as a result, they're going to choose their human capital investment, their preferences over human capital. I should really say they should choose their career trajectory in order to maximize their lifetime earnings. So the worker is just trying to maximize. We can say that their utility in terms of W1 and W2 is just W1 plus 1 over 1 plus R W2, right? They're just trying to maximize the present discounted value of their lifetime earnings because we know that W2 is going to be given by their marginal revenue product in period 2 as a function of H. This is just W1 plus 1 over 1 plus R times their marginal revenue product in period 2 as a function of H. And let's make this a little bit more concrete by saying that their marginal revenue product in period 2 is given by some specific functional form. Let's say it's going to be $10 plus 4 times h to the 1/2. So we can say their preferences are going to be W1 plus 10 plus 4 h to the 1/2 all over 1 plus r. Great. So this is the worker side, right? This is what the workers care about. So then we want to think about, well, what do the firms care about, right? We know that the firms are going to try to maximize their profits, their total profits over 2 periods. So for the firm, right, I'm going to maximize pi of h and W1, which is just going to equal MRP1 minus W1 plus C times H. And I'm adding this C term here. This is basically going to be a cost for the worker, for the firm of providing human capital, which I'm adding just to make this problem a little bit more interesting. And then plus 1 over 1 plus R times MRP2 minus W2, which, as we just said, is just equal to 0. So the firm is just trying to maximize their profits, which are marginal revenue product in period 1, minus the wages plus the cost of human capital investment in period 1. And I said this, but I didn't write it down. So just to be clear, the C here is the cost to the firm of each unit of human capital they provide. So C times H is the cost to the firm of human capital investment. Okay, so given this, what's it going to look like when we're in a competitive equilibrium? Well, just like with any other provision of benefits, we can draw a graph where we have the wage rate W1 and the benefit level H, right, the amount of human capital we're going to provide. And we can say that the firm has isoprofit curves, right, that look like this, where this is the direction of more profit. And the slope of the isoprofit curve, right, is going to be the cost per unit of H over the cost per unit of W. So the slope is going to be C, right? And then we're going to have, for the workers, indifference curves like this, right? And we know that our optimal choice of W and H has to be here, where the slope of the worker's indifference curve, that is the MRS, is going to be equal to the slope of the firm's isoprofit curve, right? And I should note, there's a couple things that look a little different about this graph than graphs like this we've drawn in the past. Maybe look a little less weird. The first thing is that it's downward sloping, both the indifference curves and the isoprofit curves. The reason for that is workers would prefer to earn higher wages and have more human capital investment. So if you're going to make them indifferent between a higher wage and a lower wage, you have to offer them more human capital investment, right? Hence downward sloping. Likewise for firms, wages are costly and human capital is costly. So in order to compensate a firm for offering more human capital, you have to give them lower wages. The other thing is the fact that we've got a straight line here for our isoprofit curve rather than a curvy line. And the reason is that we've made this assumption in the way we've written down the problem that the cost per unit of human capital for the firm is constant, right? If we had some increasing cost per unit of human capital, then we would have the slope the way that we're used to. Okay. So given this, what we're going to do is we're going to use two conditions here. The first condition, right, is that we're going to have the MRS equal the slope of the isoprofit curve, right, which is going to be d pi dh over d pi dw1. And the second is that our firm has to be earning zero profit, right, in order to be at a competitive equilibrium. Okay. So if we start with our first condition here, right, that our MRS, which is going to be essentially the amount of wages that a worker is willing to give up for a unit of human capital, has to equal the amount of wage that a firm is willing to pay in order to avoid having to invest in a unit of human capital. So our MRS is going to be du dh over du dw, which is going to be, right, 2h to the minus 1/2 over 1 plus r all over 1. Right? And d pi dh over d pi dw1 is just going to equal c. So this is going to tell us 2h to the minus 1/2 over 1 plus r equals c, right? Which is going to tell us that h is going to equal, you can multiply both sides by h to the 1/2, divide both sides by c, and say h is going to equal 2 over c times 1 plus r, the quantity squared. Right? And then from our zero profit condition, we can say W1 is going to equal our marginal revenue product minus H Okay. So I want to take a minute to think about what this is telling us. So the first thing here is we have a level of human capital investment, a level of on-the-job training that is going to be lower the higher the interest rate is, right? And lower the higher the costs are to the firm of providing human capital investment. And if we'd had an ability term here, right, if instead of 4h to the 1/2, we had AH to the 1/2, it would be higher if we increased ability, which you can check on your own if you'd like. So something I want to note is that this doesn't depend at all on the value to the firm of providing of acquiring those skills in the second period, right? It doesn't matter here whether this firm benefits a lot from having workers with high levels of human capital or doesn't benefit very much from having workers with high levels of human capital. Instead, the only reason that the firm matters in this problem is because of the fact that some firms have higher costs for providing training than others. In other words, we can basically imagine that some firms are going to end up specializing in providing human capital to early stage employees because of the fact that they have low training costs, regardless of their demand for the skills they're training in the future. We can think, for example, if we thought from a sports example, right, we could think about baseball farm teams or soccer leagues like I guess the Dutch league tends to do this, right? There's teams that essentially specialize in producing really high quality athletes. We can think of this in a labor market context as there being apprenticeship programs, right, or internship programs that specialize in, are designed to increase the skills of their employees, and as a result, don't need to pay their workers very high wages. Another thing to note is that the solution we're getting here is basically just like school, right? The firm-specific, the general human capital investment decision looks just like a worker's human capital investment decision, right? The amount of human capital a worker is going to get is going to depend on their own preferences, right? Which in a non-credit constrained context is going to depend on their own lifetime, maximizing the present discounted value of their own lifetime earnings. But if we added credit constraints, would depend on their preferences over the present and the future, right? It's going to depend on the worker's own abilities. And then to a certain extent, it's going to depend on how useful this firm is as a provider of skills. But essentially, we can think about firms that are providing general human capital as being kind of like schools, right? We can think about a continuum. Instead of thinking of school and work as completely separate things, we can think of a continuum where in one extreme, you're going to end up with maybe an actual school where you have a marginal revenue product that's 0, and therefore your wage is going to be negative, right? You'll have to pay tuition to go to school. And then on another extreme, having jobs where you're not really trained at all, and therefore your wage is exactly equal to your marginal revenue product. The other thing is, everything we talked about as issues when we think about human capital investment in school are going to be issues with human capital investment with general training. So a lack of credit, right, a lack of access to credit is going to mean that more skilled and less patient workers are going to get less human capital investment than they would if they lacked credit constraints, in the exact same way and for the exact same reason that less patient and more skilled students are going to get less education if they lack access to credit. And this underlies a lot of the discussion, a lot of the argument about whether or not we should allow, for example, unpaid internships, right? Which are a version of, a situation where essentially your marginal revenue product exactly equals the cost of your training. A lot of that discussion comes down to whether there's unequal access to those sorts of programs based on your ability to go for an early period of life without any income. In exactly the same way that we talk about access to college as having financial barriers.